Luis Castillo of the Cincinnati Reds is one of the MLB's best starting pitchers. While he is better known for his blazing fastball and arguably the best changeup in the game, I think his slider is his most interesting pitch from a physics perspective. It doesn't sweep like Chaz Rowe's slider or float like the slider of Eliza Hernandez. Instead, it barely moves at all. According to Baseball Savant, it has averaged 0 inches of horizontal movement this season. Some have moved slightly glove side while others have moved slightly arm side, but on average, they've been straight as an arrow. But this does kind of raise the question, what is movement? I mean, the concept seems simple enough. You take the initial trajectory of the ball, see where it's headed, and then measure the distance between that point and where the ball really ended up. That distance is the ball's movement. And this works for most pitches, but not Luis Castillo's slider. Why? Because it actually changes direction mid-flight. So it's mostly gyro spin to start, but it has the slightest bit of arm side spin. So it just kind of moves right. It kind of moves right at the beginning of the flight, but as the gyro spin becomes side spin, that gyro spin starts moving it left. So it starts right and then moves back left, and ultimately it finishes on the same line. So Baseball Savant's like, yeah, I mean, it ended up on the same line that it started out on, therefore 0 horizontal movement. But from the batter's perspective, it started off kind of fading right, like his fastballs do, like his changeup does. But then it breaks left. So from the batter's perspective, Luis Castillo's slider doesn't really have 0 horizontal movement because it starts right, then breaks left. It kind of does a little juke. Now, that's not on the same level as Chaz Rowe's sweeping slider, but it's not 0. It is not straight as an arrow. It kind of comes down to the physics idea of distance versus displacement. Take a look at these two lines. Now, they are both going from point A to point B. So measuring by displacement, they have the same amount of movement. And this is kind of how Baseball Savant does it. It takes the starting point and measures at the finishing point. But as you can see, they don't have the same distance because this one's going all over the place while this one was a straight line. And this is obviously a more extreme example than Luis Castillo's slider. I mean, if you measure by distance as opposed to displacement, it's only like 3 or 4 inches of movement, but it's not 0. And more specifically, the 0 doesn't capture what it's doing. See, Luis Castillo's slider has gyro spin like this. So it starts right, then breaks left. But if it was spinning the other direction, it would start left and break right. But Baseball Savant wouldn't know the difference because they had the same amount of vertical drop and the same amount of horizontal movement. Baseball Savant's not wrong. It's designed to say how far apart 2 different pitches with the same initial trajectory will finish, not really how they get there. Luis Castillo's slider does not stand alone with this problem. The sliders of Robbie Ray, Herman Marquez, and Amir Garrett, the cutter of Max Scherzer, and even the fastball of Tyler Glasnow, in having average horizontal movements around 0, they run into this distance versus displacement problem. With so many pitches sitting around 0 inches of horizontal movement, there's just a lot of detail being lost in the game. It wouldn't hurt to have a few movement metrics that measure the equivalent of distance as opposed to displacement. After all, understanding exactly how these pitches are moving could help unlock a new level of understanding. Well, I hope you learned something and enjoy the rest of your day.